In lesson 6.2, we were talking about all of the properties of a parallelogram. And in lesson 6.3, we're going to talk about what conditions need to be met in order to determine if our figure is a parallelogram. And basically, you can think about it as taking all of those properties, taking the converse of those statements. But we're going to look at those conditions. The first one, it says that if both pairs of opposite sides of a quadrilateral are parallel, then the quadrilateral is a parallelogram. So that's basically using the definition of a parallelogram. If you can prove that both pairs of opposite sides are parallel, that's going to prove it's a parallelogram. Box number 2, if you can prove that both pairs of opposite sides of your quadrilateral are congruent, that is enough to say it must be a parallelogram. Box number 3, if you can prove that both pairs of opposite angles of your quadrilateral are congruent, the quadrilateral is a parallelogram. Now, we need to add a little note here. If we proved that our opposite angles were congruent, it would show a parallelogram. But we also could prove that by talking about the consecutive angles. Remember that we said the consecutive angles are supplementary. So we can also prove a parallelogram if both pairs of our consecutive angles are supplementary. Taking a look at box 4, if the diagonals of your quadrilateral bisect each other, it is enough to say you have a parallelogram. And finally, in box 5, if you have one pair of opposite sides of your quadrilateral that is both parallel and congruent, the quadrilateral is a parallelogram. So they're going to ask you to take a look at some figures and to determine if your quadrilateral is a parallelogram. And sometimes these can be kind of tricky. You need to really take some time to investigate them. Now, whether you decide yes or whether you decide no, I also want you to justify your reasoning, to do some explaining. So let's take a look at figures 1, 2, and 3. We are deciding, is our figure a parallelogram? Figure number 1. Well, in figure number 1, I can see I do have a pair of opposite angles that are congruent. But that does not tell me anything about the other pair of angles. It doesn't tell me anything about the side lengths. And so really, that's the only thing that I know. I'm going to have to say no at this point. I cannot say that it is a parallelogram. I only have one pair of congruent angles, and I need 2. How about figure number 2? When I look at figure number 2, I can see that my opposite sides have the same length, and so yes, that is enough information to say that it's a parallelogram. My opposite sides are congruent. Could write that, or maybe I'd even say by box number 2 on our notes. How about number 3? I take a look at number 3. I have one pair of opposite angles congruent. I have one pair of opposite sides congruent. But yet again, I don't know anything else, and it doesn't tell me anything about these other angles or the other sides, and so I'm going to have to say no. I just don't quite have enough information. I either need another pair of angles, or I need to know that some sides are parallel, or another pair of sides congruent, something else. Taking a look at the back side, we have a couple more figures that we want to take a look at, figures 4, 5, and 6, and we want to decide if we think that we have parallelograms. Again, I also want you to justify your reasoning. Figure number 4. Now this one is pretty tricky. When I look at figure number 4, I do have one pair of sides that is congruent. But you know what? Because these angles are same side interior and they equal 180, that would also prove that this side is parallel to this side. And so I'm going to be able to say, yes, I can say this is a parallelogram. One pair of sides is both parallel and congruent. Or on the front side of our notes, that kind of follows box number 5. Let's look at figure number 5. Well, there's a few different things that are true about figure number 5. Can we say that it is a parallelogram? Yes, we can. And there's a few different ways that you could explain it or justify it. But maybe the shortest way is to look, if this is a triangle and this is a triangle, we know by the third angle theorem that this angle would have to be congruent to this angle. Well, that in fact would make our opposite angles congruent. Lastly, figure number 6. I don't know anything about my angle measures in figure number 6, and I have some congruent sides, but if you look, by the markings of my tick marks, these sides congruent, those are consecutive sides. They are not opposite, as well as these. And so no, I'm going to have to say that does not prove that this is a parallelogram. That actually would show that we had a kite. Moving along to example number B, or letter B. It says that PQRS is a parallelogram, and I'd like you to show that for value of A equaling 2.4 and B equal to 9. How do I show that? Well, when I look at having to do with my variable A, I see that it has to do with my side lengths. I know that my opposite sides should be congruent. So if I wanted to show parallelogram and A is 2.4, I'm going to go ahead and come over here and say, well, a little bit. 7 times 2.4 should really be equal to 2 times 2.4 plus 12. My opposite sides equal to each other. We go ahead and do some calculating. This would give me 16.8 equal to 4.8 plus 12, which just shows 16.8 equal to 16.8. What does that mean? Well, QP must be congruent to RS. Okay, but we're not quite done. That doesn't show parallelogram. But as I take a look at my value B equal to 9, and I see that has to do with my angle measures. Well, these angles are consecutive, and we know that my consecutive angles should be supplementary. So I'm going to go ahead and show that when I plug in 9, so 10 times 9 minus 16, plus 9 times 9 plus 25, that should equal 180 degrees. And doing a little simplification here, 90 minus 16 plus 81 plus 25. This would give me 74 plus 106 does in fact equal 180 degrees. So what have I shown? I have shown that angle Q plus angle R what that means is if those are supplementary, that allows me to say QP is parallel to RX. Now these three little dots here mean therefore. So if angle Q plus angle R equals 180, therefore that shows QP is parallel to RS. Parallel here. How have I shown that I have a parallelogram? Well, we have shown that we have one pair of sides is both parallel and congruent. Now they're also going to ask you to do a little bit of solving. So in example C, they're asking me to find the value for the variable so that it would make my quadrilateral a parallelogram. And as I look at example C number 1, if I wanted this figure to be a parallelogram, what would have to be true? Well, showing my diagonals, I know that the diagonals need to bisect each other, meaning that this side and this side would have to be congruent, likewise this side and this side. Now when I write my equations, I see I have x and y, and a lot of times we have a habit of solving for x first. Well, this gives me 3x equal to y. I can't really do much with that. So let's go ahead and look at the other equation, 2y minus 7 equal to y plus 2. Well, I can see here that I'm going to have to solve for y first and then use that information to solve for x. So if we were to get our y's on one side and our numbers on the other, we would find out, okay, well, y has a value of 9. If y is a value of 9 and I plug that back in, that would mean x must have a value of 3. So in order for this to be a parallelogram, I would need x equal to 3 and y equal to 9. Question number 2. Well, I can see question number 2 has to do with my angle measures. There's a couple ways that you could look at this. You could look at your consecutive angles, needing to add to 180, or we could look at our opposite angles being congruent. I actually first like to look at my opposite angles being congruent would mean they would equal each other. And I can see that I can pretty easily solve for my x value because 7x equal to 56 allows me to say, well, x must be 8. And my second set of angles, I might have to do a little bit more work. 4y plus 4 should equal 5y minus 26. If I add 26 to both sides and I subtract 4y, well, we actually find out that y is equal to 30. Okay, let's take a look at our very last example, example D. Example D gives me the following, JKLM. They want me to show that the quadrilateral JKLM is a parallelogram. Now, JKLM is graphed on the coordinate plane, and I like to graph it simply to give me a visual, but graphing it is not required. Okay? The one thing you just would want to keep in mind is that these vertices are consecutive. Now we want to think about how would I show that that's a parallelogram? Well, we could show that many different ways. We just talked about all the conditions that need to be met. What about tying it in when it's graphed on the coordinate plane? Well, the definition of a parallelogram says that my opposite sides are parallel. So would you agree to show that these opposite sides are parallel? I could take a look at using my slope. But to be a parallelogram also says that opposite sides are congruent, and maybe I could take a look at finding the length, which would mean we'd use the distance formula. So when I take a look at example D, I have a couple options. I could think about using the slope of my sides, or I could think about using the length, which would mean we are using the distance formula. Now, if I chose to use the slope, I need to make sure that I pair up my sides, opposite sides. And let's say that we are going to take a look at finding my slope for JK. I know slope being y minus y over x minus x. This one's a little tricky because we have a lot of negative and minus signs we need to keep track of. Well, -1 minus -6, -4 minus a -1. I'm going to compare that to my slope for Lm, y minus y over x minus x, 0 minus 5, 7 minus 4. Well, let's take a look at these. Guess what? A slope of 5 over -3 and a slope of -5 over +3, those are actually the same. Right? It doesn't matter if the negative is on the top or the bottom, it makes the whole fraction negative. So I've proven that two sides are congruent, but I also need to, two sides have the same slope, but I also need to take a look at my other two sides, my long side of KL and JM. KL, well, y minus y over x minus x. I would get 6 over 8, but I know that can reduce to 3 over 4. And JM, 0 minus -6 over 7 minus -1, 6 over 8. So that also has a slope of 3/4. So we have shown that our opposite sides are parallel because they have the same slope. Now, if you are more comfortable using the distance formula, we could do that as well. We would simply want to show that these have the same length. And so if I'm showing that they have the same length and I'm looking at JK, I'll just remind you, my segment JK, the distance formula being x, -1 there, x minus x, quantity squared, plus y minus y, quantity squared. And we would have to do a little bit of simplifying. Now here, we would end up 3 squared and 5 squared. So this would be the square root of 34. And now let's compare that to Lm. We would have x minus x, quantity squared, y minus y, quantity squared, again 3 squared and 5 squared, so that again equals the square root of 34. So these two segments, this shows that they have the same length. And then I would simply need to do that for my other two segments. KL, x minus x, quantity squared, y minus y, quantity squared. See, it looks like we're going to have 8 squared and 6 squared. Well, that would be the square root of 100, which I know to be 10. And JM, x minus x, y minus y. And again, it looks like we are going to have 8 squared and 6 squared, square root of 100. Now, if I show all of my opposite sides are congruent, I have shown that JKLM is a parallelogram. If it would so happen that one of these would come out different, or that my slopes were different, that would show that it is not a parallelogram, and that's the conclusion that you would draw. If you have more questions on this, please come in and see me.